Hello guys and welcome back to my channel. In today's video, we will learn about web cache poisoning by solving a PortSwigger lab titled Web Cache Poisoning with an unkeyed header. To help us solve this lab, we will use a popular Burp Suite extension called Param Miner. But before we jump into the practical part, let's start with the basics. So what exactly is web cache poisoning? Well, web cache poisoning involves exploiting the behavior of a web server and its cache to inject malicious content. So the goal is to have the cache deliver a harmful HTTP response to unsuspecting users. Alright guys, to really understand this vulnerability, we need to have a basic understanding of how web caches work. Alright? So as we can see here, the web cache is basically a layer that is sitting between the users and the server, the web application server. So in this example, let's say that user A is fetching some resource. For instance, an HTML page, a JavaScript file, etc. The server then receives the request and sends the response back. When the cache sees this resource fetched for the first time, it will save a copy in order to serve it to other users that are making the same request. So in the case of user B and C, they are trying to fetch the same resource as user A. So now what will happen is that the cache will compare the cache key belonging to the request that user B and C made and compare it with the cache key of the previous request which was made by user A. Since they match, the cache will directly serve the response to the users without needing to interact with the server. And now you might wonder, what exactly is a cache key? Well, it typically consists of the request line, as we can see here, and the host header. So any other part that are not included in the cache key are referred to as unkeyed inputs. They can, for instance, be headers, cookies, and so on. And it is really important to note that unkeyed inputs are ignored by the cache when deciding whether to serve a cached response to the user. And therefore, unkeyed inputs that are supported by the server can be used to inject payloads to induce a malicious response, of course with the intention of caching it. And once it's cached, this malicious response will be served to all users whose requests have a matching cache key. Manually finding unkeyed inputs can be very tedious and time consuming. Instead, we will use a Burp Suite extension called Param Miner to automate the process of finding unkeyed inputs. And after finding the unkeyed inputs, we need to elicit a harmful response from the backend server, and we need to get the response cached. Alright guys, enough with the theory, let's go ahead and solve the lab. Alright guys, so now we have the lab up and running as we can see here, and I have also downloaded the Param Miner extension, which is developed by James Kettle. Let's go ahead and navigate to the proxy, turn on the intercept and refresh in order to capture a GET request. And then let's go ahead and right click, navigate to extensions, Param Miner, guess params, and now we have several options here. Since we know that we are dealing with a header, so unkeyed header, let's go ahead and select this option. Alright, and we don't need to change anything in the configuration here. Let's just use the default settings. Let's go ahead and click on OK. So now the Param Miner is running in the background and sending a series of requests to the target. If a request containing one of its injected inputs has any effect on the response, then the Param Miner will log this in Burp. And the log, you can see it in different places depending on which Burp Suite you have. If you have the professional version, you can see it on the dashboards. And as we can see here, I already have some issues registered. We can see it under the issues activity. But if you have the community edition, you can view it under, let's see here, under the extensions and then installed and under the output. Alright, so the Param Miner has already identified an issue, so let's go ahead and click that. It is telling us that it has found an unlinked parameter, which is X forwarded host. Alright, so let's dig a little bit deeper. We can see that the Param Miner has sent several requests. So if we have a look at the first one here, so as we can see here, this is basically the untampered request. So it doesn't contain the X forwarded host. So this is just the regular or the normal request. And we have its response here. This is just for benchmarking, you can say. Then we have request 2, which is actually manipulated. We have injected the X-forwarded host and its value, which is a string value. And what we want to do now is we want to copy this value and see if it is reflected in the response somehow. So let's go ahead and navigate to response 2. And here we can see that the header was in fact reflected inside of the source attribute. And since we are able to manipulate the source attribute, we can effectively inject malicious scripts. Alright, let's proceed to request 3. Here we can see that we have the X-forwarded host, but after that we have some gibberish here. So let's go ahead and copy this again and see if it is this value is reflected in the response. And it is in fact not reflected. So to summarize, we have now found an unkeyed input, which is X-forwarded host, and it is in fact being reflected in the response. Alright, so how do we proceed? Well, as I mentioned earlier, we are in control of the source attribute, as we can see here. So the thing that we want to do now is to set the source attribute to an external resource, to our exploit server that contains a malicious JavaScript file. So our intention is to basically make this page load our malicious script. So how can we do that? One important thing that we can see is that we are in control of this part right here. And then we need to have this path, which is /resources/js/tracking.js. All right. So let's go back to the lab. Let's go ahead and navigate to the exploit server. Here we can see the file path, and as I mentioned earlier, we need to have the same path as the one here. Let's just maximize this really quick, copy this one, and go back. There we go. And inside the body, we want to have an alert. All right, so alert document.cookie. Just check everything is okay. Yes, let's go ahead and store this payload. And let's copy the URL. We only need this part right here. Let's go back to the lab here, turn on the intercept, refresh, and we want to add the header, the unkeyed header. And now we want to add the URL that we have right here, just to this point right here. We don't need the /resources/js tracking because this will be added automatically. So let's go ahead and copy that and input it right here. Let's just send it to repeater to see what is going on. We are getting an error, as we can see. So let's go ahead and, of course, the HTTPS is not required here. So let's go ahead and send it again. There we go. Now it has missed the cache. Let's send it again. All right, so now we have hit the cache, meaning that we have managed to cache this response, which contains our payload. Let's see where that is. Source. There we go. Yes, here is the URL to our exploit server. Okay, so this seems really promising. So let's navigate back to the lab and let's refresh. There we go, guys. As you can see, an alert containing our cookie has appeared, which means that we were able to execute a cross-site scripting attack via web cache poisoning, and thereby we have solved the lab. In this video, we explored the theory behind web cache poisoning and successfully solved a PortSwigger lab titled Web Cache Poisoning with an unkeyed header. If you found value in today's content and want to support my channel, please consider subscribing. Thanks for your support, guys, and see you in the next one.